Fatty acids are long chains of carbon atoms with a carboxyl group at one end. So we can name them in a few ways. So there's the omega notation and the delta notations. First, I want to start off with the delta notation. So for example, let's take oleic acid, which is an 18 carbon fatty acid with one double bond. In omega notation, we'd call it omega 9 because the double bond is 9 carbons away from the end of the chain. In delta notation, we'd say 18 colon 1 delta 9. This means there are 18 carbons, one double bond. Notice it doesn't specify where it is, just saying that there's one double bond. And then the 9 refers to at which carbon the double bond is. So the double bond is at the 9th carbon. It's like giving the fatty acid a street address depending on which end you're counting from. Now, the structure of fatty acids depends on whether they're saturated or unsaturated. So saturated fatty acids have no double bond, so the chain is straight and packs pretty tightly, right? Kind of like uncooked spaghetti stacked neatly. Unsaturated fats, on the other hand, have one or more double bonds, which introduce bends or kinks in the chain, so an assist or transconformation. That's more like cooked spaghetti that's bent and tangled, so it can't pack and so neatly and tightly, right? So this difference in structure directly affects the membranes. Saturated fats makes membranes more rigid because they line up closely, almost like bricks in a wall. Unsaturated fats increase fluidity because the kinks keep them from stacking too tightly, more like a pile of bent straws with gaps in between. For example, let's take stearic acid, which is a saturated fatty acid, and it tends to make the membranes more stiff, while oleic acid, which is unsaturated, adds fluidity to the membrane. So the cell adjusts this balance like a thermostat. More unsaturated fats keeps membranes flexible in colder temperatures, while more saturated fats keeps membranes stable in warmer conditions. So in all, naming fatty acids is like giving them an address. Their shape depends on saturation, and that shape is what controls how fluid or rigid the membranes are, and it's almost like deciding whether your wall is made of straight bricks or bent straws.